69. Find the value of m that makes the line y equals negative 6x minus 9 tangent to the curve f of x equals mx squared plus 6x plus 3. Well, if it is tangent, then we know two things about a tangent line. We know that the tangent line touches our curve at a single point. If it touches it, it means at the same x value, their y values are the same. So that means negative 6x minus 9 can equal mx squared plus 6x plus 3, assuming that that x in this equation represents the x value of the intersection point. So there's one equation. What's the other equation we get? Well, we know that the derivative of the function has to equal the slope of the tangent line, which means my tangent line slope is negative 6. So negative 6 has to equal the derivative of f of x. So it has to equal 2mx plus 6 right there. So if 2mx plus 6 equals negative 6, then negative 12 has to equal 2mx, which means negative 6 has to equal mx right there. Oop, my alarm's going off. That means it's time to go play backgammon. Let's finish this problem, though. So I see that negative 6 equals mx, and I want to substitute that in. And there are different ways you can go about doing this, but I think the cleverest way to go about doing this is to write, all right, negative 6x minus 9 will leave you the same, equals mx squared means mx times x. And we know mx is equivalent to negative 6. So I will replace that mx with a negative 6, which means mx squared becomes negative 6x. Sick, plus 6x, even sicker because those cancel now, and plus 3. So negative 6x minus 9 equals 3, which means let's subtract 3 from both sides. So negative 6x minus 9 minus 3 is minus 12 equals 0. So 6x has to equal negative 12. So x has to equal negative 2 is totally not my answer. We want to find m, but we know that mx equals negative 6. So m has to equal negative 6 over x, and we know x is negative 2. So m equals negative 6 over negative 2. 6 divided by 2 is 3. So m equals 3, and we're good.